Yeah. Hi, Dhananjay. Am I audible?
Yes, ma'am, you are.
Okay, fine. Where were you since last few days? Nobody was joining, even not Shreyasi and even you.
Ma'am,
Was there any?
actually, from the past few days, I wasn't at home only.
Okay. Not from past 2 days. Long back I have seen since last 4 5 days. Because
Yes, ma'am.
meanwhile there was off, right?
Yes, ma'am. 3 4 days I wasn't there.
Yeah, I haven't seen you. Just give me a while.
Yeah, ma'am,
Let
sure.
me keep my like this is on charge.
Okay.
So today we are going to learn about the thermodynamics. Okay. This is a chapter 6 from your chapter from your syllabus. Okay. And I hope both of you are going to join for the 11th grade classes. Is it so?
Ma'am, maybe I may not.
You're not interested? Why?
No, ma'am. Actually, my college timings are from 7 o'clock to 7 o'clock.
Yeah, actually tomorrow onwards classes are going to be start. You might have got this message. I just wanted to convey, so I conveyed once.
Ma'am, so today is the last day of bridge course.
Yeah, most probably.
Okay, ma'am.
Yeah. So see what thermodynamics concepts are. One by one, we are going to check. Fine. That's what I said. Now you have lost many classes. Fine. So what is the system? Okay. The system is refers to the portion of universe which is under the observation. Means suppose anything is there in a beaker, you have a substance. Two substances are there, A plus B. They are reacting with each other inside the beaker. So whatever material inside the beaker which you are going to observe, that is called as system. Okay. And the whatever part around that beaker, that may be a room, maybe a wall, right? That is called as surrounding. Okay. So system what? That refers to the portion of universe which is under observation. And what do you mean by surrounding? Surroundings are everything else in the universe except system. It's called as what? Surrounding. The universe is equal to system plus surrounding. Clear? So here you can check. These are the surrounding. This is what? System. And this entire would be what for you? Universe. Okay? Fine. Now what about the open system C? In a system, when there is an exchange of energy and a matter taking place with the surrounding, then it is called as what? Open system. Means suppose beaker is there, reaction is going on in between A and B. Okay, beaker is open and exchange of energy and matter would be takes place in this. What has been exchanged? Energy and matter. Both are exchanged. This is called as what? Open system. What does it call? Yes, Shreyasi, Dhananjay. It's called as what? Open system. Fine. Okay. Fine. After that, see the next one. We have learned about the open system. Now we are going to see the closed system and the isolated system. So what is the closed system? I'll let you know. The presence of reactant in an open beaker, they've given here. The presence of reactant in an open beaker is an example for the open system, correct? Closed system means what? A system is said to be closed. For example, when the presence of reactant in a closed vessels made of conducting material. Means material can be exchanged, but then, material can't be exchanged, but then energy can be exchanged. That time it is called as closed system. But we have learned first of all, open system, right? In open system, what we have done? We have exchanged what? Both the things. Exchange what? Material and energy. In case of closed system, what we do? In closed system, we exchange what? Material only. We cannot change, can't change material, but can change energy. Exchange, can exchange energy. Okay, means metal utensils you may see. If it is closed, you can exchange the heat energy, you can exchange the thermal energy, but then you can't exchange the material. Material will not go out. It will be inside. But then what happened? Heat will be come out. So this is what? A closed system. Apart from that, the next one is what? Isolated system. In the isolated system, nothing can be exchanged. Okay, neither material nor energy. Example is given here, thermoflask, right? Yes or no? Thermos you might have seen. Whatever temperature you will be fixed, that at that temperature only material will remain as it is for the longer period of time. Yes. In a system, when no exchange of energy or a matter takes place with surrounding is called as an isolated system. Example is given, presence of reactant in the thermoflask or the substance in an insulated closed vessel is an example for isolated system. So system means the material under observation, and surrounding means except than a system, anything else around it is nothing but a surrounding. System is of three different types: open system, closed system, and isolated system. Open system, in that what we can exchange material and energy both. Closed system, in that we can exchange only what? But we can exchange only energy. Material cannot be exchanged. And in isolated system, we can't exchange material as well as we can't exchange energy. Neither material nor energy. Clear? Yes, Dhananjay, understood.
Yes, ma'am. Yes, ma'am.
These are the, yeah, these are the points. Apart from that, see what we are going to achieve further. It's been shown here, isolated system. You can check matter will not be exchanged, energy also will not be exchanged, right? And system are of different types, homogeneous system and the heterogeneous system. What is the homogeneous system? What is the homogeneous system? A system is said to be homogeneous when all the constituents present in the same phase or in a uniform phase throughout the system. Example is given, a mixture of two miscible liquids. Miscible liquid means which can dissolve into each other, right? Miscible is kind of word soluble. For the solid, we use a term soluble. For the liquids, we use a term miscible. Okay. When two liquid can dissolve in each other, it is called as miscible liquids. So homogeneous system means what? A system said to be homogeneous when all constituents present in a same phase or in a uniform phase. Correct. And heterogeneous means a mixture is to be heterogeneous when it consists two or more phases and composition is not uniform at all. Example is given, insoluble solid in water. Any insoluble solid if you take and check the water, that time you will come to know that would be the heterogeneous system, right? Yes or no? If I give you an example, can you tell me whether it is homogeneous or heterogeneous? Yeah. If I add salt and water, what it will be? And if I add oil plus water, what it will be? Yes, Dhananjay?
Oil and water is hetero, ma'am. And salt and
This one
water is
would be homo, right? Homogeneous, because they can dissolve with each other and can give a single phase, right? And if you dissolve oil into water, oil will not dissolve at all. It will give you two different phases. Two layer will be obtained, right? And hence it is heterogeneous. Clear? Fine?
yes, ma'am.
Yeah. Now see the next point. Yeah. The states of system is given to you. See what is this? The states of system. The states of thermodynamic system means its macroscopic or a bulk properties. which can be described by state. They are also known as state functions, right? The state of the system means what? State of thermodynamic system. Its macroscopic or bulk properties, which can be described by what? State variables. What are the state variable or the state functions? First one is a pressure, second is volume, third is temperature, and the amount N, right? What are the state function for the state of system? Pressure, volume, temperature, and amount or the quantity. So in that first one is given you isothermal process. What is the isothermal process? Right? In that C, what is given to you? Isothermal process. When the operation is carried out at a constant temperature, the process is said to be isothermal. Means heat will not be goes out. For isothermal process, delta T is equal to 0, where delta T is change in the temperature. Understanding? Isothermal process means what? When the operation is carried out at constant temperature. Temperature remains constant. It will not change. And change into the temperature is shown by dt. Okay, or delta T. So that is 0, means it will not change at all. Understand? So isothermal process will take place at a constant temperature. Then the next is adiabatic process. It is the process in which no transfer of heat between system and surrounding takes place. Heat will not be changed. Okay. Isobaric process. When the process is carried out at constant pressure, it is said to be isobaric pressure, isobaric system. At that time, change in pressure remains constant. Isochloric process, a process where it is a process when carried out at a constant volume. It is known as isochloric in nature. Understanding? See, first one is what? Isothermal at constant temperature. Adiabatic, no change into heat, either not in system, even not in surrounding. Isobaric at constant pressure. Isochloric at constant volume. Now, what is the cyclic process? That too we supposed to check. Understanding or not? These all things understood or not? Whatever I have explained. If not, let me know. I'll explain it again. Yes, Dhananjay?
Yes, ma'am.
Understanding?
Yes, ma'am.
Okay. Can you tell me what do you mean by isothermal? What is isothermal process?
From the process will be with constant temperature, ma'am.
Write down somewhere at the corner of your notebook or at the back side of your notebook. Here. Isothermal means constant temperature, right? Adiabatic means constant heat, right? Isobaric, constant pressure, right? And isochloric means constant volume. Okay? Write down at somewhere in the corner of your notebook. Here, dt is equal to 0 in a first process, and for the constant pressure, dp is also equal to 0. Clear? Yes?
Yes, ma'am.
Now we are going to learn about what? Cyclic process. What is given about the cyclic process? See, if the system undergoes a series of changes and finally return to its initial state, it is said to be cyclic process. Means suppose A is converted into B, B is converted into C, again C is converted into D, and after that D is again converted back into A. So such a process is called as what? Cyclic process. A system undergoes a series of changes and finally return to its initial state. It is said to be a cyclic process. And what do you mean by the reversible process? When in a process, a change is brought in such a way that the process could at any moment be reversed by an infinitesimal change, and change R is called reversible. When suppose A is converted into B, and at any moment B can be converted into A. Such a process is called as what? Reversible process. Means it will be turned back into A at any moment. That is a reversible process. Understand? So when a process is changed abroad in such a way that the process could at any moment be reversed by an infinitesimal change, and change R is called as reversible change. Understood? Yes, reversible change means can be returned to its original state. It won't be cyclic, okay? It won't be cyclic. Cyclic means number of changes would happen and again it will be come back into A, means your previous state. And here what happened, A will be converted into B and B immediately convert into back at any moment by doing infinitesimal changes. That is called as what? That is called as what? Reversible change. Fine. Now see the next one. Internal energy we are going to learn about. Okay. Okay. Now check here what is given about internal energy. Fine. It is the sum of all the form of energy that a system can possesses. What is the internal energy? It is the sum of all the forms of energies. That energy can be in the form of electricity, that can be in the form of heat, that can be in the form of enthalpy, entropy, etc. Okay. If you sum up all the energy that is a system possesses is called as internal energy. In thermodynamics, it is denoted by AM. Okay, which may change when AM will change, when heat passes in or out of the system, when work is done or by the system, or matter enters or leaves the system. Three possibilities are there when internal energy would be changed. So what is the internal energy? First of all, it is the sum of all the forms of energy that possesses by the system, right? In thermodynamics, it is denoted by what? AM. And AM would be changed by what? When heat passes or comes out from the system. Then when work is done or by the system. Then matter enters or leaves the system. That time changes into the energies will take place. And on that factor, AM is depend. AM is nothing but what? Your internal energy of system. Internal energy of system. Fine. Now see, change in internal energy by doing work. What is given over here? How changes are happened in an internal energy when work done happens. Let us bring the change in internal energy by doing work. Let initial state of the system at the state A, and the temperature would be TA. At the initial state, temperature would be TA, and internal energy what? Small UA, right? Yes or no? Initially, the state will be A, temperature would be TA, and internal energy what? Small UA. On doing some mechanical work, a new state is called state B is obtained. That time temperature become TB, and it is found to be TB is greater than TA, because initially your object or your system would be on rest. That time it does not do any sort of work, right? When it done the work, that time energy require more, and hence your TB is always greater than TA. Understand why TB is greater than TA? Because in case of TB, work done is happened. So TB is greater than TA. Now UB is the internal energy after the change. So what would be the change in internal energy? Delta U. Delta is nothing but denoted by the change. It is nothing but a change, right? So delta U is equal to UB minus UA, right? So change in internal energy by the transfer of heat. This is what? By the work done. Delta U is equal to UB minus UA. This is change in internal energy when work done is happened. Now we are going to check how change in internal energy would be takes place when heat is loss or heat is gain, or change in heat is happened. That we are going to see now. For that reason, see what is given over here. Fine. Changing internal energy by the transfer of heat, right? So internal energy of a system can be changed by the transfer of heat from surrounding to the system without doing work. So in this case, work is not happening. So delta U is nothing but what? Q, where Q is nothing but the amount of heat absorbed by the system. What is the Q? Amount of heat absorbed by the system. So internal energy change is completely depending upon the change in into heat. It can be measured in terms of temperature differences. How we can measure the heat? Heat can be measured in the terms of temperature differences, right? So here is given Q is positive when heat is transferred from surrounding to the system. When heat is positive when heat is transferred from surrounding to system, and heat or Q is negative when heat is transferred from system to surrounding. Okay, when change of the state is done both by doing work or transfer the heat, that time delta U would be what? Is nothing but change into the heat plus work done, right? So first law of thermodynamics states your law of conservation of energy. It stated that energy can neither be created nor be destroyed. The energy of an isolated system is constant, right? And that would be proved by this. Internal energy delta U is equal to Q plus W. Means total amount of heat exchange plus amount of work is done. Okay. So by that you are able to calculate the internal energy. What is the first law of thermodynamics? It stated that energy can neither be created nor be destroyed. The energy of an isolated system is constant. Because in isolated system, what we know? Energy neither be created, energy neither be lost, neither be gain. Material neither be lost, neither be gain. It will be remains constant, right? Yes or no? And in this way, you can say in an isolated system, energy can neither be created nor be destroyed. This is the first law of your thermodynamics. If you want to write down in your notebook, you can. It's important. Fine. Dhananjay, understood or not?
Yes, ma'am, I understood.
Shreyasi, then would be your Q value would be positive. Whenever heat would be lost by surrounding and gain by system, right? And when heat is lost by system and gained by surrounding, in that case, it would be negative. And with that, if there would be a change in if there would be a change in work done, that time you have to add that W also with that change in heat. Okay. Understood? Yes or no? So that would be what? Delta U is equal to, come on, tell me, Q plus W. Clear? Yes?
Yes, ma'am.
Fine. Now the next point which we are going to learn, that would be work, pressure, volume, work. Like work we are going to learn, and how does it affect with the pressure and volume. Okay. Yeah. Check out what is given to you in your diagram. In front of you, diagrams are there. Check what things are given in that. Let us consider a cylinder which contains 1 mole of ideal gas in which frictionless piston is fitted. Right? Yes or no? What? नाही येत. गावात गेले. Here, let us consider a cylinder which contains 1 mole of an ideal gas in which a frictionless piston is fitted. Now, frictionless piston means what? When it come up and when it goes down, that time friction will not be happen. Okay, means it does not lose or gain any sort of energy when it will move. That you need to keep it in your mind. Now, what is given here? A diagram. Okay, this would be your initial pressure P, right? Then Px area is equal to what? Px into delta V. It's given. You can check here. Previously, the system would be in this manner. This is a frictionless piston. When it will be compressed, volume would be decreases, right? Pressure increases, and this would be nothing but the length. Work done is a isothermal and reversible expansion of ideal gas. It's given over here. Work done in isothermal and reversible expansion of ideal gas. See what is given in this in detail. Yeah. Isothermal reversible expansion. In this case, what you come to know in the previous state, first state, work done is nothing but what? Change into the pressure and the change in volume, right? Your pressure is also has been changed and volume is also changed, right? So they have given work done is equal to integration of negatively sign V1 to V2, P extensive into dV, right? Then they have given you what? Again, minus integration of V1 to Vt, nRT upon V. Why nRT? Why nRT we have written? Any guesses? Because here P extensive is there. dV as it is. P extensive is nothing but for the ideal gas nRT upon V. Correct? So in that nRT is constant. It's been taken out. From the integration, you get minus nRT as it is. Under the integration V1 to V2, what you will get? dV upon V. dV upon D is nothing but what? Minus nRT. That would be a ln V2 upon V1. Okay. Volume in a second state upon the volume into the first state. So isothermal and free expansion of ideal gas is given below. For isothermal expansion of an ideal gas into volume where work done is equal to 0. That time how you're going to do? See this. This I'll explain it once again. Work done with respect to what? Pressure and volume they asked, right? So pressure was how much over here? Pressure P extensive. I'll show you the diagram first again. Already we have seen this diagram. You can come to know. See here. Earlier it was here, your piston would be here, right? The extensive pressure would be applied, right? When you applied the pressure, it gone over here, right? Are you able to see this cursor?
Yes, ma'am.
Yeah, here was the pressure, you applied the pressure P extensive over here. And when you press it, what happened? Frictionless piston, it will go down, okay? Much distance would be changes, right? And volume is get decreased. It goes from V1 to V2, correct? So change in volume is equal to delta V and the pressure is nothing but P extensive, right? And hence in isothermal reversible expansion, what we are going to write? We are going to write in this way. Right? Work done is equal to minus integration in between V1 to V2 because this is a change in volume, P extensive into dV. Correct? This minus sign will be as it is, right? In between V1 to V2, right? And P extensive, this is for what? Your ideal gas. Ideal gas pressure is nothing but nRT upon V, right?